Hi everyone, welcome to our next video for week 3. And in this video, we're going to discuss how we can tell when the problem is asking about raw data versus when it's asking me to use the central limit theorem. So for a normal distribution of raw data, we're using symbols that are labeled with x's instead of x bars. So mu sub x, sigma sub x, and that z-score formula looks just like we saw it a few weeks ago, x minus mu divided by sigma. We know that we're asked about a regular normal distribution when we're told the distribution is normal. We have to know the raw data is normally distributed to use normal CDF. And typically, we're not given a sample size. Another good clue is that they're asking us about a single data value, or we're given a single data value. What is the probability that a single runner had a time that's less than 52 seconds? What is the probability that a single person is taller than 7'2"? The central limit theorem, on the other hand, has to do with sampling. We're looking at samples of a given size and how those sample means are distributed. So the big clue is you're going to be given a sample size, and they're going to be asking you about probabilities for sample mean. And you will see those words used over and over again: sample size, sample mean, sample size, sample mean. And we know that if we're dealing with samples out of a population instead of just raw data from the population, our mean is the same as the raw data, mu sub x, but our standard deviation is modified. It's the standard deviation of the raw data divided by the square root of n, the sample size. Let's take a look at a couple of word problems. And for this video, we're going to focus just on, is it normal distribution or central limit theorem? And then in the next video, we're going to go through and actually solve those problems. So for example 1, it says an adult on average has 5.2 liters of blood. Assume the variable is normally distributed and has a standard deviation of 0.3. Find the percentage of people who have less than 5.4 liters of blood in their system. So reading that problem, they give us an average or a mean, 5.2 liters. And then they say, assume the variable is normally distributed. And we know that the variable is the liters of blood in an adult. And they give us a standard deviation. And then it says, find the percentage of people who have less than 5.4 liters of blood in their system. At no point in this word problem have they mentioned sample size. At no point have they talked about find the percentage of people who have, or find the percentage of samples that have a mean that's less than 5.4 liters. They're specifically talking about individual adults and no mention of sample size. So this is strictly a normal distribution. So X is normally distributed. We're told the average is 5.2. The standard deviation is 0.3. So this is straight normal CDF with these values. We don't have to use the central limit theorem. Okay, so next example says the average age of a vehicle registered in the US is 8 years or 96 months. Assume the standard deviation is 16 months. If a random sample of 36 vehicles is selected, find the probability that the mean of their age is between 90 and 100 months. So reading that problem, first thing they say average age of vehicles registered is 8 years. So they're telling us that our random variable is average age of vehicles registered. Well, actually, let me correct that. It's age of vehicle registered, sorry. It's been a long day. And that the average, mu, is 8 years or 96 months. It says, then assume the standard deviation is 16 months. So this is the standard deviation of the raw data. And then they come and say, if a random sample of 36 vehicles is selected. So they're giving us a sample size of 36, and they're asking us to find the probability that their mean age is between 90 and 100 months, meaning they're asking us about that sample mean X bar, not an individual vehicle. So the two things that tell me that this is likely central limit theorem and not regular normal distribution, I'm explicitly asked about the probability of the mean, and I'm given a sample size. The other thing that I'm not told is when they talk about X, I'm not given a distribution. They don't tell me if this is normally distributed, if it's uniform, if it's bimodal, if it's skewed. I know nothing about the distribution of ages of vehicles in the US. So all of those pieces together tell me that this is definitely a central limit theorem problem. And we know for central limit theorem that the sample means follow a normal distribution with the same average as the raw data and a standard deviation that's modified by the square root of the sample size. Okay, let's try one or two more just to make sure that we've got the idea of how we're parsing this information out of a word problem. Because I know in stats, those word problems are probably the scariest part. So example 3 says a study reported that children between the ages of 2 and 5 watch an average of 25 hours of TV per week. Assume the variable is normally distributed and the standard deviation is 3 hours. If one child between 2 and 5 years old is randomly selected, what is the probability that they watch more than 26.3 hours of TV a week? If 20 children between the ages of 2 and 5 are randomly selected, find the probability that the mean number of hours they watch TV will be greater than 26.3 hours. So we'll start the same way we did before. Let's pick through this problem, look at what we're given, and identify what we know. So children between the ages of 2 and 5 watch an average of 25 hours of TV per week. Seems to be our random variable. And that 25 is that average for the population. 25 hours per week for all children between the ages of 2 and 5. They do tell us that X is normal, distributed, and that standard deviation is 3 hours. Part A then says if one child between 2 and 5 years old is randomly selected, what is the probability that they watch more than 26.3 hours per week? So all of this together, the word problem plus part A, indicates that we're looking at raw data, and this is just regular old normal distribution. So until we get to B, we haven't seen any mention of sample size. We're explicitly told that our variable is normally distributed, and the probability is specifically asking about an individual and not a group of kids. So we know that X is normally distributed with a mean of 25 and a standard deviation of 3. For part B, it then says if 20 children between the ages of 2 and 5 are randomly selected, find the probability that the mean number of hours they watch TV per week will be greater than 26.3. So for B, they're giving us a sample size n is equal to 20, and they're telling me that we're looking at sample means instead of raw population data. So those two pieces of information tell me that this is a central limit theorem problem. And for the central limit theorem, we know that the distribution of sample means should be normal with the same mean as the raw data and a standard deviation that is the raw data standard deviation divided by the square root of the sample size. So this problem gives you both. Part A is specifically asking about one child. Part B is asking about a sampling distribution for groups of 20 children. So it is possible to see both in the same problem, and it's really important to look for those keywords. You will notice here that I'm marking up my paper. If you've got a hard copy of the book or you've jotted it down, feel free to mark it up. If you don't have a hard copy of the book, make these notes on your paper, right? Jot down what you read. X is hours of TV per week. We know X is normal. We know what the mean is. We know what the standard deviation is. You can jot these down so that you can keep track of what you're thinking as you're reading and parsing that problem out. So don't be afraid to mark things up or jot your notes down kind of in an informal fashion before you start the formal problem solving. Okay, last one. This one says a desktop PC uses 120 watts of electricity per hour based on 4 hours of use per day. Assume the variable is approximately normally distributed and the standard deviation is 6 watts. What is the probability that a single PC will use less than 106 watts per hour? If 500 PCs are selected, approximately how many would we expect to use less than 106 watts per hour? So start same way we did before. Desktop PC uses 120 watts per hour based on 4 hours of use per day. So we know we're looking at watts of electricity per hour as our random variable. They've given us the population mean, sigma sub x is 120. They've given us the standard deviation, sigma sub x is 6 watts. And they've told us normally distributed. And when we go down to A, it says, what is the probability that a single PC will use less than 106 watts? So all of that tells me this is just regular old normal distribution. I don't need to use the central limit theorem because I'm just looking at raw data. So we know that our random variable X, watts of electricity per hour for a desktop PC, is normally distributed with a mean of 120 and a standard deviation of 6. For part 2, we get a little bit wonky, for lack of a better word. It says, if 500 PCs are selected, approximately how many would we expect to use less than 106 watts per hour? So you'll notice this question's not asking us about finding the probability for a sample mean for 500 PCs. They're saying if I had 500 PCs, how many of those PCs would I expect to fall in that less than 106 watts per hour group? So this has nothing to do with the average wattage usage for a group of PCs. It's actually a completely different question. It's asking, based on our answer to A, we now know the probability that a single PC will use less than 106 watts. In other words, I know the percentage of PCs that will use less than 106 watts. Can I use that percentage and the fact that I've got 500 in PCs to figure out how many will use less than 106 watts? So B actually isn't asking about a normal distribution or a sampling distribution. It's asking you to use that probability you found in A to make a prediction. So this is actually neither, and we're going to look more closely at this in our very last video for the week. Okay, so I'm hoping that seeing a couple of those word problems broken down gives you a better idea of what to look for when you're looking at word problems in this unit. Again, that next video, we're going to come back and actually solve those. If you have any questions about what you've seen, contact me. Otherwise, I'll see you in the next video or in office hours.